In today's session, we'll see a problem on moment distribution method of a continuous beam with a sinking support case. For sinking support case, so the problem is determine the support moments for the continuous girder shown in the figure. If the support B sinks by 2.5 mm for all members, take I equal to 3.5 into 10 power 7 mm per 4 equal to 200 kN per mm square. So given A, B, C, D continuous beam. There is UDL on AB and CD, and there is a point load between B and C exactly at the center. The point load is 100 kN. UDL on AB is 40 kN per meter, UDL on CD is 50 kN per meter, and spans are shown in the figure. Solution: in the first step, we need to fix the intermediate support. So fix the intermediate support. So at B and C, place the fixed supports. And then step 2, calculate the fixed end moments. We need to calculate MFAB, MFBA, MFBC, MFCB and MFCD and MFDC. So here on for MFAB minus WL square by 12 because it is UDL. At B there is sinking, therefore minus 6 EI delta by L square. Why minus here? Because when we know that when right side support is downwards and left side support is upwards, we need to take anti-clockwise, that means minus. So minus 6 EI delta by L square. Similarly vice versa. So here we'll substitute all the values, we'll get minus 41.67 kN meter. For MFBA also we need to take anti-clockwise, that means minus. So for MFBC it is reverse, that means we need to take plus. Because for sinking support case, if the left support is downwards and right support is upwards, we will take clockwise movement. That is, therefore we have taken plus 6 EI delta by L square here. So MFCB and for MFBC and MFCB, it is we'll get an additional moment, fixed end moment, plus 6 EI delta by L square along with the minus WL by 8. In the same, so next for MFCD and DC, there is no sinking here. Therefore, B is not there here. So as usual, we need to take minus WL square by 2, WL square by 2. We'll get minus 37.5 plus 37.5. Then free end moments we need to calculate. So maximum bending moment for AB is WL square by 8. For BC is WL by 4 point load. For CD is WL square by 8. We'll get these values 45, 50, and 56.25 kN meter. Next, we need to calculate the distribution factors. So we have joints B and C, members BA, BC, CB, CD for BC. Then distribution. So then K, stiffness K. We know that it is the formula is IL by, and when the far end is pinned or any other support other than fixed, we need to take 3 by 4 I by L. As we have all the supports fixed here, we will take I by L. Therefore, for BA, I by 3, I by 2, I by 2 and I by 3. Then sigma K, 2I by 6 plus 3I by 6, 5I by 6. 2I by 6 by 3I by 6, you will get 2 by 5, that is 0.4. Similarly, 3I by 6 by 5I by 6, 3.6. 3I by 6 divided by 5I by 6, 0.6. 2I by 6 divided by 5I by 6 is 0.4. These are the distribution factors, 0.4, 0.6, 0.6, 0.4. The next step is moment distribution table. So first we need to write joints A, B, C, D, then members A, B, B, A, B, C, C, B, C, D, D, C as shown in the table. The distribution factors we need to write 0.4, 0.6, 0.6, 0.4. Then fixed end moments we need to write, which we have calculated in step 2. Then we need to balance here. So 18.33 plus 1.25 is 19.57. But here with opposite sign we need to multiply with the distribution factor. Minus 19.57 into 0.4. 0.4 is a distribution factor. So minus 7.83. Again here also 19.57 into distribution factor 0.6. Minus here opposite side, so minus 11.75. Similarly 51.25 minus 37.5, 13.75, minus 13.75 into 0.6 distribution factor minus 8.25, minus 13.75 into 0.4 minus 5 minus 5.5. Then carryover moment, so half of the moment minus 7.83 by 2 minus 3.92 in the opposite side. and minus 11.75 by 2 minus 5.88, minus 85.25 by 2 minus 4.13. Similarly, minus 5.5 by 2 minus 2.75. Then we need to calculate final end moments. Minus 41.67 minus 3.92 minus 45.59. Similarly, 18.33 minus 7.83 10.5. Similarly, 1.25 minus 11.75 minus 4.13 minus 14.63. Similarly, we need to calculate all the final end moments. Now we need to see whether we are getting same values or not, like 10.5 and minus 14.63. There is a lot of difference. So again we need to repeat the procedure. So 10.5 minus 14.63, so and so value. So opposite sign into distribution factor. Then carry over moment. Then again calculate final end moments. And if we are not getting the same values then at the joints, then again we need to repeat the procedure. Again balancing, balancing opposite sign of balancing into distribution factors and carry over moment. Again calculating final end moments. We need to repeat this procedure till we get the same values at the joints with opposite signs or with opposite signs. Yes. So after making few iterations, we got the final end moment values. MAB equal to minus 45 plus 116 kilonewton meter, MBA 11.44, MCB MBC minus 7.816, MCB 40.6, MCD minus 40.14, MDC 35.68 kilonewton meter. Then we will need to draw the bending moment diagram. So in bending moment diagram, first we will draw the free end moments and then we can draw the final end moments. For the sinking support case, there will be additional fixed end moments due to sinking of support. For any span of length L, if delta is the difference of level of the end support, then at each end the fixed end moment will be 6EI delta by L square. The nature of fixed end moment is clockwise at each end when the right support is at higher level and left support is at lower level, and vice versa. That means if the nature of fixed end moment is anti-clockwise at each end, if the left support is at higher level and right support is at lower level, as shown in the figure.